We're going to review the topics from 2.1 to 2.3 for our quiz. So in section 2.1, we talked about graphing systems of equations to find a solution. And in order to do this, we're going to use Desmos. All right. So what I'm going to do is I'm going to have Desmos open, and I'm going to use that to know what my equations look like so I know where my solutions are. Okay, so for our first system, y equals negative 5 halves x plus 3 and x plus 2y equals negative 2. So I'm going to graph the lines from Desmos. So y equals negative 5 halves x plus 3. So now my y-intercept is positive 3, and my slope is negative 5 halves. So I'm going to go down 5 and right 2. So here is the first line. Okay. The second equation, x plus 2y equals negative 2. It's going to have a y-intercept of negative 1 and a slope of negative 1/2, which is down 1, right 2. And there's our second line. So now the solution is their intersection point. So the point where my two lines intersect is at 2, negative 2. Remember, we write a solution as a point, x comma y, and we must include our parentheses. Okay. Our second system is x plus y equals 3 and x minus 2y equals 0. Okay, so if we are graphing our two lines, start with the first one, x plus y equals 3. We have a y-intercept of 3, and my slope is going to be negative 1, which is down 1, right 1. Okay, so here is our first line. Our second line, x minus 2y equals 0, is going to have a slope of a y-intercept of 0, and then a slope of 1/2, which is up 1 over 2. All right. So here's our second line, and then the solution is their intersection point, which is the point 2, 1. These are definitely easier to see in Desmos because you can actually click on the actual intersection point and it's going to give you the solution written as a coordinate with the parentheses, x comma y. So make sure you're utilizing Desmos, or if you have your own graphing calculator and you want to solve it that way, that is another option. So section 2, we took a look at solving systems of equations using substitution and elimination. So I'm going to do an example of each, just so you have it. So remember, on the quiz, sometimes you're going to be able to choose which method you want to use, and sometimes you're going to be told which method to use. So it's a good idea to know how to do both, even if you prefer one over the other. So our first system is y equals negative 5x minus 4 and 10x plus 2y equals 4. So the type of, this is the perfect type of system of equations to use substitution because I know what one of my variables equals. We know that y equals negative 5x minus 4. So I'm going to take that and plug it in for y in our second equation. So it becomes 10x plus 2 times negative 5x minus 4 equals 4. My next step is going to be to distribute the 2 into the parentheses. So we get 10x minus 10x minus 8 equals 4. Now 10x minus 10x is 0. So I'm left with negative 8 equals 4, which is not a true statement So this is a case of no solution. So no solution happens. You put it over here as a star. Both variables, well, one variable so variable cancels and left with untrue statement. So if you want to put that kind of to the side here as kind of an indicator, if you're using substitution and your variable cancels and you're left with an untrue statement, then it's no solution. Now if I had been left with the statement -8 equals -8, which is a true statement, then it would have been infinitely many solutions since I had a true statement. So now we're going to do an example of elimination. So if you remember what I talked about, I prefer using elimination if both equations are already in standard form. So one of the first things I look for is if there's a variable that already has opposite signs. And in this case, the y's already have opposite signs. One of them is a positive 3y, the other one's a negative y. The second thing I look for is, can I make those variables have the same coefficient by only multiplying one of the equations? In this case, I can. If I multiply the second equation by 3, they will both my coefficients will be the same but have opposite signs. So rewriting my system, I leave the first equation alone, x plus 3y equals 24. After multiplying every term by 3, we end up with 6x minus 3y equals -3. Now remember, we always add the two equations together. All right. X plus 6x is going to become 7x. The whole entire point of elimination is to eliminate a variable. In this case, it's the y's, equals, and then we get 21. We're going to divide both sides by 7, and we get x equals 3. Now that I know what x is, I plug it into one of my original equations to solve for y. I'm going to pick the first equation. So we have 3 plus 3y equals 24. We're going to subtract 3 from both sides, so we get 3y equals 21. And then we're going to divide both sides by 3, and we get y equals 7. So if this is a short answer problem, you can leave it as x equals 3, y equals 7. Or you can write your solution as a point. And remember, we always write it as x comma y, 3 comma 7, with parentheses. Now you could have chosen to solve for x here, eliminate x here, by multiplying that first equation by -2. I could have solved, eliminated x by only multiplying one equation, but it would have been multiplying by a negative, which I try to avoid if I can. So question 3, we get to use a method of our choice. We have y equals 1/2 x plus 2 and -x minus 4 equals -2y. So when it says you can use a method of your choice, it does mean substitution or elimination. It also means you could technically use graphing. So that is a method to solve. Now, so I would not use elimination here. So if I'm going to use a method, it's going to be substitution or graphing. Now here's like my thought process on it. It's set up as y equals something, so I could use substitution. It also has like a fraction in it. It kind of makes me want to use Desmos, but I'm going to show you how it works with substitution. You can also use Desmos if you want. So because I know that y equals 1/2 x plus 2, I'm going to plug that in for y in my second equation. So we get -x minus 4 equals -2 times 1/2 x plus 2. Then I'm going to distribute the -2 into the parentheses. So we have -x minus 4, and then equals -2 times 1/2 is -1, so we get -x. And then -2 times 2 is -4. Now if I notice here, I have the same thing on both sides. So like if I were trying to solve for a variable, I would be adding x to both sides, and I'd end up with -4 equals -4. So my variable cancels, and I have a true statement. This is an example of infinitely many solutions. Okay, so if I were to graph this in Desmos, I would actually see that my lines overlap. They're the exact same line. So if something in Desmos is the exact same line, that also means infinitely many solutions. It is not all real numbers. So a few people put that on the assignment, all real numbers. We can't actually use that because the only solutions to our system are points that are actually on each line. So there are specific solutions. There's just an infinite number of those because lines go on forever in both the positive and negative direction. So it's infinitely many because our lines go on forever. So if we're going to kind of like make a note to ourselves, so if we're talking about a graph, they are the same line. All right, if we're talking about using the equations to solve, the variable cancels and have a true statement. I could actually even solve my equation even further and add 4 to both sides. And get 0 equals 0. That's still a true statement, even if it's 0 equals 0. So there's 2 ways to determine graphically and using like a method, substitution or elimination. If we're thinking back to number 2 where we used substitution to solve, if we were to look at a graph for no solution, you would have 2 parallel lines, because when you graph 2 equations, never intersecting means they would have to be parallel, because 2 parallel lines are never going to touch. So if you want to add that to question 2, is that when you're looking at a graph, it's 2 parallel lines, just to kind of help remember. So last thing we did was word problems using systems. That was section 3. Okay. So in our first example, we have an investor buys a total of 360 shares of 2 stocks. The price of one stock is $35 per share, while the price of the other stock is $45 per share. The investor spends a total of $15,000. How many shares of each stock did the investor buy? So the first thing you need to do in a word problem is define your variables. Okay? If you don't know what your variables represent, it's going to be very hard to create your system. So if I look here, I have 2 stocks. That's what my equations are going to represent. So I'm going to let X be the number of shares for stock 1, and Y be the number of shares for stock 2. Okay? And that's what my 2 variables represent. The next thing I want to pick out is the information that it's going to tell me what my 2 equations are. So my first sentence tells me I have a total of 360 shares. So that means the number of shares from each stock has to be 360. So X plus Y equals 360. The other information is that I know the price of one stock is $35 per share. The price of the other stock is $45 per per share, and we spent a total of $15,000. That's going to give me my second equation. So $35 for my first share stock, so 35x, plus $45 per share for my second stock, so 45y, equals 15,000. So now that I have my two equations, I want to use substitution or elimination to solve. Now you can always choose. So you can always use substitution here if you want, or you can always use elimination. I'm never going to tell you which method to use for a word problem. Sometimes substitution might be easier, sometimes elimination. It's really your choice. So because I'm a person who prefers elimination, I'm going to go ahead and use elimination here. So if I notice, I have the equation x plus y equals 360. So I can easily eliminate either variable x or variable y by multiplying that first equation. And I'm going to choose to multiply that first equation by negative 35. So I don't have a choice here. If I want to eliminate x or y, I have to multiply by a negative. So I didn't really have any other choice. So my first equation, once I multiply everything by negative 35, becomes negative 35x minus 35y equals, and then 360 times negative 35 is going to give us negative 12,600. My second equation is 35x plus 45y equals 15,000. So one of the reasons I chose to eliminate x is to avoid any negatives when I added my equations together. So I'm still attempting to avoid negatives in some way. So the x's are going to cancel when I add them together, and negative 35y plus 45y becomes 10y, and negative 12,600 plus 15,000 is 2,400. Then we're going to divide by 10, and we get y equals 240. Now I am allowed to leave my answer as y equals here as long as I've defined my variables. Like if I didn't know what x and y represented, and I just left this as y equals, you wouldn't get full credit because I don't know what y means. Y could mean anything. It could be number of elephants. It could be number of potatoes. Who knows? But because I know y is the number of shares of stock 2, I know what that 240 means. Now I want to solve for x. Right? So when I'm picking the equation to plug y back into, I'm noticing I have an equation that's x plus y equals 360. That's the equation to plug it back into. X plus 240 equals 360. If you have an equation that's x plus y equals something, always plug it back into that equation. That's going to be the easier one. Or if you have something that's already x equals or y equals, make this easy on yourself. Use that equation to plug it into. So I'm going to subtract 240 from both sides. I'm going to get x equals 120. So again, I can only leave this as x equals y equals because I've defined my variables. If I didn't define my variables and I just started with two equations, I would have to write my solution as a sentence telling me how many of each share I purchased. Now the one thing we cannot do with word problems is write our solution as a point, because you don't have to use x and y as your variables. You could use any two variables. I could have used a and b, s and t, d and f. Like I could have chosen any two variables, which is why we don't write our solutions as points for word problems. So our second example says Calvin mixes candy that sells for $2 per pound with candy that costs $3.60 per pound to make 50 pounds of a candy selling for $2.16 per pound. How many pounds of each kind of candy did he use in the mix? So remember, we start off by defining our variables. So we're mixing two types of candy. So X is going to be pounds of candy 1, and Y is going to be pounds of candy 2. All right. So this is a little bit trickier of a word problem. So my first equation is going to come from the fact that he made 50 pounds of candy. So I know that when I add the number of pounds of candy together, we have to get 50. So the amount of pounds of candy 1 and candy 2 have to add up to give us our 50 pounds of whatever our new candy is. Okay. Next thing I want to look for, the next thing I'm going to do is the part that involves the money. All right, and this is where it gets kind of tricky. So candy 1 is $2 per pound, so that's 2x. Candy 2 is $3.60 per pound, so that's 3.6y. Okay. Here's where it gets in tricky. It's like, what are we equal to? We're not equal to $2.16. We're equal to the amount of money he's making off of that new candy. So that's where we take the price of the new candy, $2.16, and we multiply it by the number of pounds of candy we're making of it. So we have to do 2.16 times 50, which is going to give us 108. So again, now I have a choice, substitution or elimination, mainly because I don't like decimals. I don't want to use substitution here because of the decimals. So again, I'm going to use elimination, and I'm going to multiply this first equation by -2 to eliminate x. So we're going to have -2x minus 2y equals -100. And our second equation is going to stay 2x plus 3.6y equals 108. I add my equations together, the x's cancel, and then -2 plus 3.6 is going to give us 1.6y equals, and then -100 plus 108 is 8. And then we're going to divide by 1.6. So 8 divided by 1.6 is going to give us 5. So we have 5 pounds of candy 2 in this mix, whatever that may be. Okay. So now to find out the amount of pounds of candy 1, again, I have an equation that's just x plus y equals a number. So x plus 5 equals 50. I'm going to subtract 5 from both sides, and we're going to get that x equals 45. So we have 45 pounds of candy 1. So again, I know this is a kind of more difficult word problem, so I wanted to make sure we did something similar to it, just in case you see something like this on the quiz. So please reach out if you have any questions over any of the 3 sections before you take your quiz.